Ruben is on a special diet. He must consume fewer than 500 calories at a meal that consists of 1 serving of chicken and 1 serving of rice. The meal must contain at least 150 calories from each. A, let X equal number of calories from chicken. Y equal number from rice. So our constraints are X plus Y must be less than or equal to 500, right? So the calories from chicken plus the calories from rice must be less than or equal to 500. Wording. Change. Fewer than or equal to. Or we can say at most 500. We need that so that we can use the vertex of the corner of the feasible region. Okay, now graph the system of linear inequalities and indicate the solution set. Graph calories from chicken on the horizontal. Okay, so I'm actually gonna, it's usually quadrant 1 that we work in, so I'm gonna make it more like this. And we have X plus Y, so this is the same as saying Y is less than or equal to negative X plus 500. So that means we're up here at 500. We're going down 1 over 1, down 1 over 1. And if you use a test point, you learn that you're going to be shading in this direction. That's the half plane that is the solution of that. And then we have, I'll do in green, this one. On this line is equal to Y is equal to negative X plus 500. And then X is greater than or equal to 1500 or 150. So this line is X equal to 150. And anything greater than is going to be in this direction. And then in pink, maybe purple. I'll use purple for this one. Y is greater than or equal to 150. Okay, so now I see a little triangle. So here's our solution set or our feasible region. We have to identify the vertices here. The one that's here in the corner is actually simple. Even if you don't see it right now, I'm telling you, it is simple. Why? Because I know the X and I know the Y. This one is 150, 150 for the X and the Y. So those should be quick for you to figure out. This one is when X is 150, I can use this equation to find Y. So it's negative 150 plus 500, so it's 350. And then here, my Y is equal to 150. So then we substitute Y equal to 150 here. So to find this one, we got Y is 150. So X is going to be, I'm plugging in 150 here, and then you subtract, so it's going to be 350. So So you're just substituting y equals 150 into this line and then solving for x. All right, we found the vertices now of our feasible region. On to question or part C. All right, so 180 calories equals 3 ounces of chicken. And 200 calories equals 8 ounces of rice. So the vertex we will have, we can do 150, 150. And we can do 150, 350. And we can do 350, 150. You're gonna need a new black marker. That one's garbage. Okay, so the number of ounces of chicken will be x times 180 over 3. Oh, no, those are calories. So we have to, I'm using dimensional analysis now. So we've got 3 ounces over 180. There we go. We're going to do the same for the rice. Okay. Ounces of rice. Ounces of rice will be y times 8 over 200. All right, so for this one, I'm going to use 150 and then ounces of rice. I'm trying to use colors here. Okay, ounces of chicken. I'm going to write it for each of them now, and you can evaluate yours. So it's 150 again, times 3 over 180. And then this one is going to be 350 times 8 over 200. And here we've got ounce of chick equals 150. Now this is 350 times 3 over 180. So on the exam, I'm going to ask you to maximize or minimize something. Using these concepts, but here these are just kind of asking for all of the answers. So this is 2.5. This one will also be 2.5 ounces. Now, second, enter, I'm just going to put 350. 5.8 ounces. Okay, now I'm going to go to the rice. 150 times 8 divided by 200 is 6 ounces of rice. Now this one is going to be 6 ounces as well down here. And then second, enter. I just modify that. So this one is 14 ounces. So if we wanted to minimize or maximize the amount of ounces of things that we were eating, we would maybe sum those up and so on. Okay, so that actually finishes this because it just wanted us to see the number of ounces of chicken or rice based on any points that are possible.